So I wanted to share a quick demo of how we can use the CheckIt Dashboard to generate new copies, new randomized copies of exercise banks, and even author a few custom exercises of our own. So you can go to checkit.clance.org, and that's where you can actually see the two currently published banks and even build quizzes and generate random quizzes to take over to in LaTeX to overlay for your favorite LaTeX editor. But I want to talk about creating new exercises that are not available on this website. So we'll go over here looking to author our own randomized exercises. And for emphasis, I'm going to open this in incognito mode. And I'm not going to log into anything. I'm not going to create an account for anything because you don't have to do this. So what we want is the CheckIt viewer is the website, but the CheckIt dashboard is what we want to use in order to create new exercises. So I'm going to open the template project, and we use the platform CoCalc to open the project with one click. And give it a few moments to boot up. This is one of something that, it takes a moment for it to boot up initially, but if you create a CoCalc account, you can actually save this as a project to your CoCalc account. That is a free service, although you'll get better performance if you actually buy a CoCalc subscription. So it's something to consider if you want to use the CheckIt platform. More than just as a one-off. But we're just here to play around with what's going on. The dashboard is the place where we can, first of all, just really quickly, I'm going to go ahead and actually let me show you that it comes with three banks. The two banks, the linear algebra and the DiffyQ bank that are on the website. There's also a demo bank, and I'm going to use that demo bank today. So let's go back to the dashboard. And so I want to preview, how do I look at the demo bank and preview an exercise? Well, it's called demo-bank. And there are two outcomes in this bank, demo 1 and demo 2. I'm going to show you demo 1 real quick. And so the instructions are right here. I just change a few of the lines here. I'm going to hit Control Enter. And because it's the first time I'm hitting it, it takes a moment for it to boot up. Again, it's one of those things where I'm using the trial version of CoCalc. So it takes a little bit longer than if I had a subscription. But there it is, and it won't be as long to rebuild a new random exercise. And so this exercise is about finding the slope from the equation of a line. So here we have a couple of lines and a couple of slopes, as we see here. And when you preview, you can preview as many as you want. Each time it'll give you different random numbers, depending on how it's written. And then if you scroll down, you can see here's a list of all the randomized aspects of the problem. Here is what that problem would be in HTML. Here's the LaTeX source. Here's the source that we use for Canvas, and here's the pretext source in case you wanted to write this for include this in a textbook that you're writing using pretext. All right, and then if I wanted to take in fact, let's just use the differential equations book because we have, or the bank, because we have on the public website, if you go to differential equations, any outcome, there are 20 versions of that outcome, and the assessment builder actually uses, I think, about 500 of them that it pulls from if you want to include a differential equations problem in your assessment. There's actually way more than the 20 that show up here. Keep clicking regenerate. But perhaps you want to create your own question bank that's not available to the public. Then you would come over here and you would build your own exercise bank using the CheckIt dashboard. All you've got to do, let's make it public false, because otherwise it'll give us the version that's on the website. So we're going to do public false. And it's now going to create, very slowly, 300 private exercises for each of the outcomes. So I say very slowly. It's not that slow, but it will take it a moment. It'll take it longer if we're going to use the free version of CoCalc, as we're doing right now. Maybe I'll just go ahead and show you. If you go back to the files, you can kind of see what is CoCalc. By the way, it is just a cloud platform for running virtual computers. And so this is actually just a directory structure. These are just files. You can download these files to your computer if you want. In particular, the files you might want to download right now are, and we did for differential equations, we built a new private bank. And if I go in here, then we could see that it's still building it. So it hasn't actually built it yet. So I'll go back here and take a look at where we're at. So it's going to take it a few moments to get all those outcomes built. But when they do, I'll come back to it in a moment. It'll be in this directory right here. Maybe I'll just kind of, while it's building, show off the structure of the bank. So in a bank, you have this bank XML file. It's like the configuration or the manifest for that bank. It's where you say what the bank's title is, the author of that bank, the URL, and then the folder that is that bank uses. And then you also, for each of the outcomes, give the title of that outcome, the folder that it's in, and then a description, and perhaps the textbook that it's being that it's based upon, where you can find more about that content. We are almost done building. So if I go back here, then in a brief moment, we could see here, we actually have now built, there they are. We have now built all three of the files that are currently built for an exercise bank. And so what we have here is the JSON file that in a future, that is used by the CheckIt viewer to make it available through the website, and also to build the quizzes through just the website. In the future, you'll actually be able to import this custom versions into the website, although that's not up quite as of today. The thing that a lot of folks might be interested in being able to do, though, is these two Canvas files. This builds out the outcomes, something that you can import into Canvas directly, and then this builds the exercise banks that you can import to Canvas directly. You can just download those using these buttons over here on the right. So that's all well and good. If I were to rebuild these, then every time I build a private version of the bank, it shows up in a new folder with a new timestamp. And so we can build as many of those as we want. Okay, but let's talk about authoring new problems. So let's go to this demo bank. And in this demo bank, I already showed off that we have two problems with this demo bank. I showed off one of them, the identifying the slope from the equation. The second one we have is the product rule, which we'll see here in a moment. Here we go. An example of using the product rule. But let's go to this. This is the differential equations bank. Let's go to the demo bank. And let's pull up its configuration. I want to add two more outcomes. Maybe instead, in addition to the slopes, I also want to do y-intercepts. I'll call that demo 3. And then identify the y-intercept. Okay, and maybe that's in section 5. All right, and then also I want to do quotient rule. And my recommendation is when you want to get into writing randomized problems is just to copy existing ones and make it fit your needs. Maybe this is section, 321. All right, so this means we need to have a demo 3 and a demo 4. So let's go into the outcomes. And so I'm going to copy demo 1 because that's the slope one. I want to make that intercepts now. I'm going to duplicate that, call that demo 3. There are two files I have to duplicate, the Ptx file and the Sage file. And I'll explain what both of those do in just a moment. So the Ptx file, this is the pretext template. And if you don't know what pretext is, it's not a big deal. All that you really need to know is that it's just sort of like HTML. It's just a language to describe your exercise. An exercise has a statement and an answer. And statements can have many paragraphs. They might have like an ordered list. And so in here, the statement says, for each of the following line equations, identify its, I want that to say y-intercept. Oh, and that y, I want that to appear like the variable y. So I'm going to make that the variable y. So I'll put it in the M tags. That's for math mode right there. Okay, and then this makes a little ordered list. And then it says for each of the lines that I'm going to generate, I want to display its equation. That's right. And the answer, I want to do that again, but I don't want to show its slope. I want to show its y-intercept, which I'll call y-int, y-int. Okay, so, well, that's great, but where do these equations and y-intercepts come from? Well, that's what the Sage file is for. So the Ptx file is like what we call a template. The Sage is what we call a generator. So this is the code that creates the logic for the randomized parts of the problem. And so let's kind of read through this for just a moment. Let's zoom in a moment here, a little bit here. So in this generator, first of all, we're saying we have two variables, an x and a y variable. And then we want to generate I spelled that comment. Random line with a slope of negative b over a. And so a is a random number between 1 and 10, including 1, but less than 10. And when I say number, I mean whole number here. And I'm going to multiply it by 1 or negative 1. Basically, I don't want 0. If I didn't mind 0, I could have done this and gotten rid of the choice. But I don't want 0. So I'm going to go ahead and leave it like this. And then I said b is the same thing, but while a is equal to b, they're the same thing. I'm going to re-roll that. So I basically want b to be something different, apparently. And then finally, here it is. Sometimes c is okay to be 0. And so in this case, it's any whole number between 9 up to 10, not including 10. And then I want this one to be a standard equation of a line. Ax plus by is equal to c. And then the slope, of course, is negative b over a. Okay, but I actually want the y-intercept, don't I? And I call that y-int. So I have to make sure I match whatever's over here and spell that the same way. And the y-int is going to be, well, what is that going to be? If I just do a little bit of math, I solve for y, divide by the b. That's going to be c divided by b. All right, and then down here I'm doing the same thing again, but this time it's slope-intercept. So now the y-intercept's pretty obvious. I'm just going to reuse that b. Like so. I still have the 2 lines that I want to display, and I want them to display in random order. So that's what that's doing. And then this says to spit out each of those lines that are looped through here and here. And then in the question, I give the equation, and the answer, I give the y-intercept. Alrighty, I think I'm done. In fact, I can go back over here and pull up demo 3. I just made this for you live in this video. Demo 3. Now, I'm identifying the y-intercept. And the y-intercept of here, this is 1. Hey, y-intercept here also happens to be 1 for that standard equation. And notice that the slope-intercept showed us up before the standard form because of the shuffling that we did right here. Oh, that's great. So let's go back, and we said we want to do one more. We want to do a demo 4, which will be based on demo 2. Because demo 2 is about product rule, I want to make a quotient rule. I'm going to sort these by name. I like that, sorted by name better. So, okay, so now we have it sorted by name. Demo 4 was about the product rule. I think this prompt can just stay the same, right? Explain how to find the derivative. I'm going to give the f, and I'm going to spit out the derivative of f in the answer, of course. So that can stay the same, but I want quotient rule. So here's how the product rule was created. I just had a bunch of possible factors. So x raised to a certain power, or e to the x, or cosine, or sine, or log. And then I shuffle those up so they're in a random order. And then this says my function is either positive or negative, a number between 2, 3, or 4, not including 5. And then I take the first and the second thing from that list, which has been shuffled up. Really, all I need to do is just change that multiplication to division. And now, here's the beautiful thing about using Sage Math, is that I don't have to actually do any product rule or quotient rule or change any of the logic, because it actually knows how to take the derivative directly. So f is f, and then df is actually the derivative. The programming language does the math for me. And if I go back over here to the dashboard, then I should have some very quickly defined quotient rule problems. As many as I want each time I hit the button. And of course, notice that it may try and do some simplification. It may not look like the quotient rule you would have expected for, like log. This is the natural log by default, and it became 1 over x, and so it kind of split it up like perhaps differently than you would get from a quotient rule, but it does very quickly get you a valid answer. And if you want to write a little bit more logic, you could make that look a little bit different if you would like. But that is the quick demo of how we can write our own problems for the CheckIt platform. And then if I wanted to include this in Canvas, well, I'll just come down here, demo bank, and run it. The last thing I would probably mention about this is that, if you're writing the demo bank, you may want to actually go back and rename that demo bank to something else if you would like. And then just make sure that you change the folder of your demo bank in your configuration there to match the new folder that you called it.